Hi, everybody. I'm John Flavin. I work primarily on pipelines with XNAT, but recently I've been developing our new Docker container-based, infrastructure. I'm going to start this talk at a kind of a high level by just talking about why do people want to process things with XNAT? Like, what is that for? What's the motivation? I will introduce what Docker is if you've never heard of it, if you've never dealt with it. I'll just tell you a little brief summary of it. And then I'll get to our specific, how we're using Docker, what sorts of things people will have to do with that. So, processing things with XNAT. There's this fundamental tension that we're trying to solve, which is people put things into XNAT, and then once they're in there, you want to do stuff with them. And to do stuff with it, you have to get them back out. You need some way to pull out just what you need, run something on it, and hopefully get things back in, but not always. And so there are a lot of different ways that you can solve this problem. Everything has to basically do these steps. Figure out what you need, and usually it's a lot of files, but you can also have like properties of XNAT objects like labels and maybe like your scan resolution, whatever properties XNAT stores, you need to be able to get them out. You need a way to make something run, and then you need a way after it's finished, gather things, put them back in. So the simplest way you can do this is just do all these steps yourself. A person can log into XNAT, push some buttons, okay, I've downloaded some files to my system. Maybe then I have to move those files over to another computer, set up all the folders and everything. This person says, okay, I want to run exactly this executable on this machine. And so they type in a command at their terminal and it launches. Or maybe in this way they could even, you could launch a GUI application. You could then pick where the files are, things like that. And then whatever you make, you then log in to XNAT. You say, okay, upload some new data, make a new assessor, whatever. So there is one benefit to this, which is you can do anything you want. It's completely 100% free form. Anything a person can do, obviously, go through those steps and you can do it. Of course, there are a lot of problems with this. It takes a lot of time. It takes a lot of time for a human being going through all of these steps. It's really, really easy to make errors. Maybe you put this file in the wrong place, or maybe, I downloaded this last week, I kind of forgot where exactly it was or what this label was. The person doing all this stuff has to be really knowledgeable. They have to know 100% what they're getting out of XNAT, where it needs to go, what they're going to run, what it produces. They're full front to back, they need to know everything. And they need to be able to get to the machines where they're doing these computations, which, for some systems, that's a problem. They don't want to have open access to a lot of these clusters necessarily. So you can get a little better than that by doing some kind of scripting, automating these tasks. So you can write a script that will go download stuff from XNAT, put it in the right place, launch some executable, and gather your outputs. So it's the same things that a person was doing, but now you just tell a computer to do it. And then somebody else, some other person can come along and launch that script. So that's a big benefit. Now you've transferred that expertise. You have a person who really has to know what they're doing. They do a lot of work up front, and then you can pass that on to other people who don't necessarily have to know as much. Since you're automating these things, you reduce the errors. You just make sure that it works once, and then hopefully it continues to work that way in the future. This is also pretty flexible. You can write a script to do more or less anything. And the person has to be an expert, but some of those things, say, if you're using a tool like PyXNAT or XNAT-Pi, you don't have to be 100% conversant in the XNAT REST API. This tool kind of has some of that knowledge, and you can learn how the tool works to abstract away a little of that XNAT knowledge. And similar on the other end, say you're using some workflow engine. And okay, this workflow engine can help me run FreeSurfer. I don't necessarily need to know 100% every little flag that every FreeSurfer command takes. I kind of get to know what the workflow lets me do, and then I get a little abstracted from the actual command. And a script is really easy to share. You got a file, send it to somebody, they can run that script. So the problems with this kind of approach are, again, there's still a person who needs to understand both XNAT and what's being executed. And again, like I said, you can abstract away a little of those, but still somebody's got to be able to marry these two things, get data out of XNAT that you need and put it into something where it can run. The person who executes the script in this scenario still has to go log onto those machines. Though maybe, you can set up some workflow engine like OpenMole, for instance. You can set that up to point to your execution machine and they just have to log into that. So yeah, there's some flexibility there. And while I said scripts are easy to share, like the literal script file is easy to share, but then actually getting that script to run in your environment can be pretty difficult. Maybe the paths to these executables are different. So, okay, how do I have to change the script to run those? Maybe the versions of these things are different. How do you even know that? Does it keep track of that? So another approach that you can take is the XNAT pipeline engine. And so it's very similar to a script in that you have these sequence of steps. Download things from XNAT, go around the executable, gather the outputs. An expert can write it, a non-expert can run it. So how is it different from a script? It has one key benefit that I think is pretty huge, is that XNAT's launching these things. Person logs into XNAT, they click some buttons or send a REST call to XNAT, and now XNAT goes and launches it. So that means the person doesn't have to have any access to the compute nodes. They just have to have access to XNAT, and then XNAT can do all that work. And then all the API features that XNAT has, now your pipeline engine has. So yeah, like I said, somebody can log on, somebody can just send up a post, you can script launching pipelines. And those schema link parameters that Mohana was showing you, that's also a huge feature, I think, because that means you can just have something that's, here's a generic variable. I know exactly how to tell this pipeline engine to pull that value out of XNAT. So at runtime, it populates that with what I need. And again, it has some of the same benefits as a script. Transfer of expertise, automation reduces errors, that kind of stuff. These resource descriptors, if you make one for basic command line tools, you can use those all over the place. So, you get some of that code reuse. So following the format of the previous ones, I'm now going to talk about some of the problems of the pipeline engine. I want to make it clear, I like the pipeline engine. I don't want to sound too harsh, but I'm also very familiar with it, and so I know where the problems are. So it can be really difficult to learn how to write pipelines. Learning the structure of these XMLs, learning exactly how you have to know how the engine executes them to really understand how to write them. You need to know how XNAT reads them to know how it's going to display when your users see them. And there's these distinctions between executables, resource descriptors, steps in the XML, all the stuff that Mohana went over. You sort of really have to get your head around that when you're writing a pipeline. And setting them up can be hard. You have to deploy the XML files to your XNAT machine. You also have to put them where they're going to be running because XNAT needs to read it on its machine. It needs to read that pipeline XML to know all the metadata. But it's actually going to run over on your compute machine. So that same pipeline XML needs to be two places. And then, you have to add pipelines to the system. And then for each project where they're going to have to run, you have to go add, there's no notion of like a global pipeline that you can just run from anywhere. More problems. The default UI for pipelines that Mohana was showing is not our best UI work. And you can customize the UI as she was showing you, but then now the person who is writing this pipeline kind of also has to know how to write a pipeline UI. And so that might involve some HTML, might involve some JavaScript, might involve some Java. And then now you're in the business of recompiling your XNAT if you have to deploy a pipeline UI. So you don't have to do that, but to get really fancy features in your pipeline UI, you're basically writing a Java screen class. So that's putting a lot of burden on the person who has to write these things. Trust me, I know. And so, yes, XNAT can launch pipelines. And that is huge. I love that feature. It's very powerful. But that's more or less all it does. Once they're started, you can't go stop them. You can't say, oh, this one failed, let me go restart it. That can't do any of that. It's just sort of throw them out there, and then if they ping back, XNAT can display that status. But once they're out, they're out. And XNAT doesn't have any notion of what the pipeline's going to need. Beyond the parameter, you can put in a schema link parameter and XNAT will provide a value. But there's no way for you to say, hey, XNAT, I'm going to need a file. Can you put that file there for me? It doesn't know how to do that. So with all those things in mind, I've been working with this pipeline engine for a long time. And so now, with this new thing, let me think about what we can do a little better. Or like the features of pipelines that we like, keep them. The features that we don't like, maybe improve. So yes, that XNAT integration, I've advocated a lot. I love it. Make it better. So yes, we can launch these things through XNAT. So yeah, have a good UI for launching them. Have a full-featured REST API for launching them. Configure them through XNAT. You shouldn't need to write a file and put it somewhere. You should be able to go to XNAT and say, hey, XNAT, I want to make a new one of these things. Show me a little field where I can fill out some things, and then boom, now I've got a new one. And yeah, deploy them through XNAT. So the executables themselves, why do they need to be on your system beforehand? Maybe you should tell XNAT, hey, I want to run this thing. Go fetch it from someplace. Give it to me. And XNAT should have more control. It should know how to launch them. It should know how to stop them, start them. A little more status information would be good. And so, yeah, they should be flexible in that if you have a workflow engine that you like, you should not need to abandon that and use the XNAT workflow engine. You should be able to keep what you like and run it through XNAT. If you have a script, say like, hey, I found this cool bash script that does what I like. I found this Python script that does what I like. You should be able to go into XNAT and say, please let me run this. And XNAT should say, yes, you can do that. You should be able to write your own new stuff, or you should be able to have somebody tell you, hey, I wrote this thing last year. Oh, you didn't know about that? And you instantly go into XNAT, get it, and you're running it. It should be easy to learn. We'll see how much I met that design goal when you guys do the practical. We'll check that. And as much as possible, we should use third-party code. So that would have a lot of benefits in that we don't have to maintain everything. If somebody else, we use their project, then they're responsible for that code. That means we're also not the only place you can use these things. If you come in with no knowledge and you learn about how to launch XNAT pipelines, but then one day you go somewhere else, you should be able to transfer some of that knowledge as much as possible to whatever else you do. And so, with these things in mind, wouldn't it be nice if we had a thing, just some, what is this thing where I can have XNAT just remotely launch some executable through some, common API? Wouldn't it be nice if that existed? Wouldn't it be nice if these things, you could move them around very easily? You could, deploy them remotely. You don't have to go fiddle around in the machine to get all your executables to work. And they're consistent across machines. You can know that I'm going to put it on this kind of system and it's going to work. I can put it on a totally different system, going to work exactly the same way. Wouldn't that be nice if such a thing existed? And that, my friends, is what Docker will do for us. So Docker, again, if you've never heard of Docker, they make containers. And a container is a packaged up little environment, sort of similar to a VM, where you can put executables, you have the whole OS, and it's all packaged up, and then you can pull it down onto your system with one command. You can run it with one command. It's really, really powerful, and you can just put anything you want into a container. And so we're going to go through some examples of what that means. So first, some terms to know. Docker is the name of the company, and it's also the name of the engine and the executable that you use. So Docker is sort of the generic term. The machine where Docker runs, I'm going to call it the Docker server or host. This can be a remote machine. So you could have your XNAT here, your Docker somewhere way over there, and they can talk to each other. In the examples, we're going to run them on the same machine. So your XNAT VMs all have Docker installed, and so they're the same. A Docker image is the thing that a developer will create. Somebody will say, all right, I want to start with Ubuntu, say, just a very plain image, and I want to load up, let's say, I want to get Python. And then I want to get these 3 Python packages, and I want to put my script into this image, and then boom, this is now a packaged thing. They can send it to people, put it up on the hub, people can pull it down. So that is a Docker image. When you want to run it, that thing that is created that is actually running is called a Docker container. And then Docker Hub, which I mentioned just a second ago, that's sort of the equivalent of GitHub. This is a website that Docker runs where you can push up your images, people can search for them, they can pull them down from Docker Hub. The generic term is Docker registry. You can run your own Docker registry if you are concerned that there might be some proprietary information inside your Docker images. You don't have to push them up to the public hub. You can run your own registry on your own network and pull your images off there. And so if you are interested in how to get this, it runs natively on Linux. On Mac and Windows, it has to run in a VM, but they sort of make that easy for you to do. You just download the Docker Toolbox. It'll put all kinds of binaries on your machine. If you're on Mac, you can use Homebrew. That's my preferred solution. And they're also in a beta of a much more native solution on Mac and Windows, so like nice, friendly native UI, that sort of thing. But yeah, you can run it on your machine, and it can either actually execute on your machine, or you can configure your machine to talk to some remote server. And so when you type Docker run this, it'll go communicate remotely. OK, so I'm going to show you a little demo of just pulling an image. So let me go over to my terminal, and I want to go into my VM. OK, so I'm on. This is the VM you'll be using for the practical, and so let's just show you, give you a little Docker. Docker's running. It'll tell you all sorts of things about what it can do. Do I have any Docker images right now? Yes, I do. I have a couple that I've pre-staged because I'll be using them later. But oh, I don't have the one I want. So let's go get a new one. So Docker pull. There's an image called BusyBox that they use in all their examples. It's a very, very tiny image. So let's just pull that down. OK, done. It just went out to Docker Hub. It found this thing. It downloaded it. And so now let's run something. So I want to run something in my BusyBox. And what am I going to do? I'm going to run shell c echo hello world. OK, and there it goes. So that didn't look like much. But that command was actually running inside a virtual machine that Docker created for me inside this virtual environment. So you'll get more better examples later. So, and just to show you that these are different environments, so I'll just do an ls of the root on this VM. Okay. So now let's go back into BusyBox, and we'll do that in there. OK, so it's different. These are different machines that I'm now running these things on. So what's the advantage of this? Like I said, this BusyBox, that's portable. Anyone can pull that down, and they will now be running the exact same commands in the exact same environment. So let's say you have some application. You can say, OK, download BusyBox, put my application on there, and then everyone who runs your application will run it 100% exactly the same. So yeah, let's see what that looks like. Let's build our own Docker image. Why don't we? So here, this is an example of what's called a Docker file. This is their little syntax for how to build an image. And so you always start with some base image. When they've got a whole library, I'll show you Docker Hub in just a moment. This one's going to be based on NeuroDebian, which is essentially just a Linux distribution with a bunch of neuroimaging packages. So it makes it real easy to get them. I've put myself as the maintainer. Just a little bit of metadata. And so this step is what we're going to run to make this image. So we're going to go update our apt packages, and then we're going to install the classic example of Daikon the Nifty. So I'll put it on here. I will cap that into Docker file. Yeah. And then I will Docker build, give it a tag, so I'll call it XNAT. And I tell it dot, which means take the contents of the current directory, go ahead and build an image out of them. OK, so now it is running that command. It's going and updating all the apt packages. And while it does that, so in that Docker file that we saw there, All of these steps are cached. So let's say you want to have a few very similar images. Say I want to change this last step. I want to install, I don't know, something else, Python, whatever. These first two steps, it will keep cached. So it won't repeat those two steps. It'll say, okay, oh, you already started with this box? Good, I have it. You already put yourself as the maintainer? Egotistical? Okay, great, I have that cached. And then it'll just run the last step again. But that means if you want to have several very similar ones, you could build like a base box, and then just the last step of each one will be different. And so it reuses a lot of those layers, that disk space, that sort of thing. Okay, so it has successfully built that container. And so let's see what that looks like. Docker run. I'm going to use that name that I gave it. And what command do we want to run? Well, let's just see what happens when I run dcm-ii. Okay, good. So it was able to just print the output. Do I have that on my system? No, I don't have it anywhere. I only have it in that Docker container. So that means I can pull down whatever application somebody puts in there, pull down and run it, even if I don't have it on my system. I don't know how to run dcm-ii. I don't know where to get that. Oh, but somebody gave me this Docker image. And so again, I'll get to more interesting stuff when we get to the XNAT integration. Okay, so return to the high level. Now remember what we're trying to do here. People want to process their data in XNAT. And so now we've seen what Docker can do. So now what can Docker do for us? How can they help us make this process of getting things through XNAT, make it better? Okay. So before I show you any of this, here's a note. And it is less for the people in this room than for the people who may be watching this video later. I'm speaking to you from the past to say, if you are using this to learn how to use this code, I'm sorry the documentation's not better. Because this stuff is going to change. Please don't learn it from this. Like, go to the wiki, please. There's going to be better stuff whenever you're watching this. Hopefully you're viewing this as a historical record. Because I've gotten famous or something. I'm president, and you're like, what was he like when he was younger?
Modest.
Could be infamous. We don't know. Okay, so yeah, we're going to have to set up this connection. So you'll have your XNAT somewhere, you'll have your Docker server running somewhere else, and they are going to communicate to each other through a REST API. Again, this can be the same machine if you want, and it'll just be two processes talking to each other. But yeah, if you want to make it totally remote, that's absolutely doable. So what can XNAT do? We will have commands within XNAT to pull new images down, delete the images that are there, just that sort of basic management kind of stuff. XNAT will be able to launch containers for you, and XNAT, one day, hopefully, will be able to stage its data to your Docker container so that when you want to run something, the command over on the Docker container can just start up and say, my data is already here. I see all of the files that I need to just start running. So yeah, what are the steps to run one of these Docker containers? So we're going to have to pull a Docker image. We have to tell XNAT the image that we have. We have to say just a little bit of what's its name, what's its ID, how does XNAT run this thing. We're going to define what I have called a command. And so going back to Mohana's talk, the command is kind of similar to the resource descriptor. It says, what's in this thing? What inputs does it need? How do I take those inputs and make a command line string that I can run? But the command doesn't know anything about XNAT. It doesn't care where that data comes from. It just says, like, I'm going to need a string here. I'm going to need these files here, that sort of thing. And where they come from, the command doesn't care. So then we'll also define a thing that I call the action. And the action is where the XNAT integration comes in. And so, yeah, again, back to the pipeline. That's sort of like the pipeline XML. That's the big global thing that says, I run on an MR session, I pull these values out, and then I take those values and I put them into these inputs, into, in this case, the command. And then that action is also, it's like a template. It just sits there, it's static. And then the thing that executes, I call an ACE, the action context execution. So that means you're not just on an MR session, you are on this specific MR session with this specific ID. So then when you go to run it, it says, I will pull out all the properties of that thing that I need, put them into the action template, and then that's what you go and launch. You launch the ACE, you execute ACE. So yeah, those commands, so here's a little graphical representation. So XNAT will communicate down to Docker server, say, okay, Docker, somebody told me they want to pull, they want to pull XNAT DCM to NII. So Docker server will then bounce up to the hub and say, do you know what this means? Did somebody pull this up? And hub will say, yes, I know exactly what that is, and then send the image back down. One other thing that we kind of just thought of, because we're using it in the practical, but we want to make the API for it, is you should also be able to just have a tarball. You can archive your own local copies of these Docker images. So we want XNAT to be able to accept that, pass that on as well. That would be a nice feature. So yeah, telling XNAT about the Docker image, it's just a very small amount of things. Just give it a name that someone can see and the image ID of what that image is out on the Docker server. And yeah, if you're using this API command to XNAT to pull it from the hub, you will also just pass these things in. But we also want to support the thing where, maybe someone, an admin has gone onto the Docker server, pulled a bunch of images down that they think they're going to need. You should be able to go into XNAT and say, hey, this image already exists. You don't need to pull it. I just want you to understand. Here's what the ID is. So let me see. I'm going to show you some of the XNAT integration. So here is the VM that you'll be using in today's practical. So yeah, the first thing we need to do is, wait, where's it? Site administration. That's the one I want. So all of these things will have a UI at one point, but right now they don't. They're completely REST API. And so we're going to use XNAT's Swagger tools, which basically, Swagger is a nice little code generation thing. It reads your REST API, and it makes a little UI that people can go explore. So we're going to use that. The alternative is me going onto the terminal and typing curl commands to do posts. And so this looks a little nicer than that. And later, we'll show you what the UI is going to look like later. So first thing we have to do is tell XNAT about our Docker server. And so I'm going to pass in a little bit of JSON, which is, where is my Docker host? So this can be a URL. In this case, like I said, they're on the same machine, and so we're going to do a nice little Docker feature where they can communicate through a Unix socket. So I'm just going to give it that. So var, what is it? Var run docker.sock. So I tell this to XNAT, try it out. And it responded with 202, which is, I have accepted this value. So how do we know that worked? There's a nice little server ping command. So that tells XNAT to go ping the Docker server. And we get back an OK. All right, so XNAT can communicate with Docker. But the interesting thing is, OK, XNAT, I want to tell you about this Docker image that I have. So I'm going to switch over here. I've got a little bit of JSON. But we need to know the image ID. So that is something that you have to come in with this knowledge. And so we will go back over to Docker, and we'll get some information about this. So I could use this. This is like the short ID. I'm actually going to go get the longer one. Docker inspect, that guy. So, oh boy, Docker knows a lot about this image. But all we really need to know, we want to know this ID. And you can see, wish I could point, but yeah, this short ID that I just used is like just the first few characters of this big long hash of the image. Okay, so I'm going to take this. I'm going to put it right into this blob of JSON, and I'm going to post this up to XNAT so that XNAT can know what this image is, what it's called, and how to address it. All right, 201 created. Okay, and it gives us back the ID. XNAT keeps track of its own ID for this image. Okay, so great. We've made an image in XNAT. Cool, cool. So now what do we do that we have this thing? We have to make the command. So the command, when you are over on your Docker server and I typed in docker run busybox that's what I want to know here. I want you to tell XNAT, how do I run this thing? What do you need? Where do I compose those things into this string? And what do I send off to Docker? So you could put in your run command, and that can be a template, going back up here. So you could say, all right, this -o opt, maybe I'm going to put some sort of little template in there, and then XNAT will know, OK, at runtime, that's a variable. I'm going to fill that in. You can have environment variables if you need them. That's a thing that Docker knows how to accept, so you can define them here. And you can define what are called mounts. So that means when my Docker container runs, I'm going to look in /input. That's where my files need to be. And so this is a thing you can tell us. You say, all right, we will stage files into /input. Or maybe you're looking in /data. Maybe you're looking in whatever. You just tell us where you want your files to be, and that's where they will be. All these things can be templatized. You can put in little template strings, and we'll go fill those values in at runtime. And again, none of this stuff needs to be XNAT specific. This stuff can all be totally generic. You don't care that it's a session label going in here when you're defining the command. However, there are some ways you can provide nice little hints of how XNAT's going to use those, and it'll make things easier later. So let me show you what a command looks like. OK, so this is a whole bunch of JSON. But the important parts are here, the run template. So this is, when I run this thing, it's going to run dcmd_nix. This right here is how I specify a variable. So if somebody sends in some command line options, boom, I'll put them right there. I'm going to say, OK, this is my output folder. And then this is my input folder. And so that means I need to specify /input and /output as mounts. I need to tell XNAT, OK, good, you're going to put files here for me, please. And so this is one of the ways you can make a hint to XNAT. So this thing is generically just a name for your mount. You could call it mount 1. You could call the next one mount 2. You could call it whatever you want. But if you call it the name of a resource where you want to pull things, that'll make it easier than when you define the action for XNAT to say, aha, yes, I see exactly what you want to put in here. So I'm going to look for a DICOM resource, and I'm going to put in /input. I see that you're going to create some Nifty files. So that's the name of the resource that I'm going to create when you're done. But again, you don't have to do that. It just means that in the next step, in the action, you will have to explicitly say, OK, I'm creating a Nifty resource. And then it refers to this mount. OK, so let's post this command up. Let's tell XNAT what we've got here. So close that one down. OK, so there's a command REST API. I'm going to post up a new command and try it out. All right, 201 created. And again, this thing has an ID that XNAT says, yeah, it's in the database. I've tracked this. It has ID number 1. So then later, when you're defining your action, and you say, what command do I need to run? You say, I need to run command number 1. Give it the ID that XNAT has given you here. OK, so now, we're on the stage of the action. I should say that you can run commands directly if you want. You won't be able to get any XNAT knowledge out of them. But say if your command just has a few variables, there is an API where you can say, just go launch this command here. I'm giving you values for those variables. Just go. So if you have something that's just kind of a global thing that you just want to run and it doesn't need any files, then you can just make a command, run a command, and you're good. But if you want to pull stuff out of XNAT, you need to make an action. And so the action says, I'm going to run on this kind of XNAT object. Give me an XSI type. You can define matchers like, OK, it has to have a T1 scan. It has to have this kind of bold scan. And if it doesn't have that, then I can't run. And then once you have that thing, the action definition will say, OK, go pull out its label, pop it into that command variable. Go grab these DICOM files out of that scan and satisfy that command's input mounts. These are the connections I'm going to make from the XNAT object down to the thing that's going to run. So like I said, it defines the root object that it's going to run on. And when you run that thing, we call that the context. That's where a user will be. They'll be in that part of the UI. That's their context. And so that defines what actions they can run. Defines how to pull stuff out of that root object and put them in the command, and defines all the resources that you want to stage. Oh, and create, and what resources are going to come out when that thing is done. What are they going to be called? How do I make a new thing out of this? So let's show you what it's like when we make an action for DCM to NIX on a scan. So this is a very short action definition. They can get a lot longer than this, but since I was clever with my foresight and I said that this mount is called DICOM, that means I don't need to say anything in the action. The action will just by default say, oh, this mount asked for DICOM, then that's the resource I'm going to get. If I wanted to do something else, I could say, OK, resources staged. OK, that's not, oh boy, whatever. I'm going to take this out, so don't worry about the syntax errors. And I make some object for what that looks like and give it whatever. But yeah, we want to be a little more intuitive about it. So we want you to provide like as few things as you need to. The command needs to be pretty knowledgeable about what goes on, but the action should be pretty simple to make. You should be able to say like, all right, oh, here's a cool command I want to run. Let me run that from a session and just boop, 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 make a few connections and it's good to go. Oh, command ID is, that's not 5, it's 1. So switch back over here, go to the action REST API, make a new one, try it out. 201 created, it's action ID 1. Great. So now XNAT knows about all the things it needs to know. So that was fun, right? Made all these objects. They're in the database. Cool. Oh, you actually want to run things. Oh, sorry, I forgot about that. OK, so resolving the ACE. So yeah, the action we just made is a template. It says, I will have a thing, something, and here's how I connect that thing. But the context is, yes, I have a specific object. I have, it has this ID. It has these properties. And so, yeah, when you go and say, all right, I want to run something, you ask XNAT to resolve all of these ACEs, and it will return, all right, these are the kinds of actions you can run here. I've filled out all their values for you, and now you can go post them back up and run them. All right, so let's do it. Let's see, what do I need? OK. Didn't write this down, so I think I remember. So you go to the ACE REST API. First, we need to get them, because the getting process is what will resolve all those values for us. And so we say, all right, here is a session. And I don't know if this is going to be the permanent solution. This is one of those areas where code might change. But right now, scans don't have a globally unique ID. So if I want to run on a scan, I have to make up a fake ID, which is the session ID, and then the scan ID. So, well, yeah, exactly. That's what I was. Yeah. So this is the ID of the session, and I put a colon and the scan ID. So yeah, I would like that to change. But right now, that's what I have to do to get the code to run, is make up a concatenated ID. And then that will be, the thing that runs in the background will say, all right, so now I know how to go get your scan and get its properties. And I have to give it the XSI type, image, scan, data. And so that's what sort of, the XSI type is sort of your first level filter. So it'll go and say, what actions can run on this thing at all? And it'll return a list of actions. And then it says, all right, now get the actual object I need. And then this action is going to define more specific properties. So can it run, I have a list of 10 actions that can run on scans, but maybe not all of them can run on this specific scan. So all right, let's try it out. OK, so here's our response body. So this is what an ACE looks like. It looks more or less like an action, except that this resource staged now has a path to that resource. And this is the path in the archive once we get the the file transporter actually working, this would be the path on the remote execution node where this data, it will have already moved the data where it needs to be and staged it up. I think, or maybe that happens later. One of those. Yeah, and so then it also knows it's going to create a Nifty resource when it's done. And right now that doesn't have a path, doesn't exist. If it did have a path, you would need to set this overwrite to true so that I can understand, yeah, I can delete this thing. You have authorized me to delete it. And at this point, we still have an input, which is these options. And right now this thing doesn't have a value. So, and this is the stage where, if you have things that aren't connected to XNAT inputs like this is just a free-form string. Somebody can enter whatever they want. So this is the stage where they can put in a value for that thing. But this one is also set to not be required, so if there's no value, then it's fine. It's an optional parameter. OK, so how do we launch it? Well, with the UI, it'll be a little bit better. The UI will do this for you. Right now, we have to copy this thing out and paste it over in the other field. So we say, yes, XNAT, you have returned a list of all of these aces that I can run. This is the one that I would like to run, please. And actually, I am going to give that options a value. Or maybe not, because maybe I'll forget. Like this thing will be passed directly to DCM to NII, and I don't remember exactly what their options are. So let's leave that blank for now. I'll have to go look at the usage again. All right, let's post it up. And 201 created. It launched a thing. Hey, all right. And this thing that it returns back it has a little more detail because when I executed that, it made a record in the database that somebody launched this thing. Here are all these parameters. Keeps track of all that information. And very key, it gave me the ID of my Docker container that it started on my behalf. So let's go see that thing. So here we are back at our terminal. And this is a thing that XNAT will also be able to do for you one day. Right now, we're going to have to do it ourselves. So let's just inspect that container. Let's just look at what it is. OK. This is a whole bunch of information. Here's the command that ran. Oh, sorry. That's fine. And OK. So let's look at the logs. Docker, by default, will capture standard out and standard error and store them in these logs. And that's another thing that, again, one day, XNAT will be able to just pull those logs out automatically and store them so you can look at them on XNAT. OK. And so I did not actually put the correct command syntax in there, and it gave me an error. It's like, sorry, bud. So what did I do wrong? I guess let's go see if what did I do in this command? Yeah, I think it didn't like that. Maybe I should have gotten options of value. OK, let's try this again. You know what? We can make this work. So I'm going to go back to this. Yeah, I am going to give it a value, and it's going to be blank. I think XNAT, I'll file a bug in my personal JIRA that it should fill those in with blank strings. OK, we made a new one. It's got a different container ID. Let's see what happened. And it gave me the same thing. So it is very possible that I just have the wrong command syntax. Well, OK, let's see if it made any files for us. It's very possible that it didn't. Nope, it made nothing. Well, hopefully I've demonstrated how easy it is for you to do things wrong in an application. It's real easy to debug these things, right? You can just go get the logs and interact with, yeah. Let's say I was better at DCM than NII. This would have worked, and I made a Nifty file. And it would have been stored right here. XNAT made a path for me for my files to be stored. It was mounted as /output, and so whatever I wrote in there, XNAT would find right here. Currently finds nothing. Remember what they said on the workshop emails? Live seat-your-pants demos, so get what you pay for. Okay, so now that I've shown you all this Swagger stuff and posting JSON, that's probably not what most people will do. They will interact with a UI. And so Will's going to come up and show you what that will look like and what he's working on.
Okay, so let's see here. First of all, I'm Will. I'm the UX and UI designer on staff here, and I've been working with XNAT for 5.5. Basically, Lauren and I, our hire dates were about a week apart or something like that. So about 5.5, 6 years. I always look to Lauren to see what work anniversary she's celebrating, and then I know how long I've been working here. I come from strictly a design and front end point of view, which means tackling problems like this is a really interesting challenge. My first job is basically to try to learn the nomenclature, learn the structure, learn the requirements, and get inside the headspace of someone who, or of each user that's kind of along the path. So the person that is an expert in Docker and knows how to write a Docker syntax and create an image, maybe that's different from the person that is an expert at the command, being able to write a really good shell script, or program inside of Python or Ubuntu, etc. And maybe that person is different from the one that they are programming for, which is going to be the person that launches XNAT, runs an action, or is a study coordinator who is organizing data in XNAT and wants to have a repeatable set of processes. And from my perspective, in terms of UI design, I had to think, for each kind of user, what do they want to see, what do they not want to see, and I think most of the users don't want to see all the JSON and stuff that we just demonstrated for you. So what we're trying to do is, am I too loud?
No, go ahead.
Is develop a front end that is going to make these same concepts a little friendlier. What I'm showing to you, first of all, is wireframes, which, well, they're actually nicer than what most people would call a wireframe. It's more of a prototype, a clickable prototype. This is not an actual web page. It is a mock-up of a web page made up of a bunch of really nicely styled clickable thingies, so that basically are entirely controlled by me. So if there's something wrong in here, it's my fault. Because this is a design, I can show you stuff that's very forward-looking in its vision for what XNAT could be. So right now, this would be what an XNAT landing page could look like in the kind of upcoming theme. And whenever we actually finalize the UI for automation, perhaps XNAT looks like this. Perhaps Flavin's the president. Perhaps I'm in prison. I mean, any number of things could happen. So I kind of make the same caveats that what we're looking at is very much a straw man. We hope to improve it and iterate upon it, a number of times, but we've got it to a point where I think it presents these concepts as they stand now in a pretty clear fashion. So we want to support the basic functions of installing, running a container service inside of XNAT, and we want that container service to be bundled with the sort of nascent ability to program custom events and to automate actions inside of XNAT that were introduced very, very quietly in 1.6.5. And we want those scripted actions to run inside of containers, because one of the big advantages of doing that is not only is it portable and repeatable, it's also insulated. So you can run these actions in a safe environment without necessarily going straight into your Tomcat and potentially wiping out your user table or something crazy like that. So in our container service and automation administration, the very first thing we want to do, oh, wait a second, we have to turn these comments off. There we go. The first thing we want to do is verify that we have a container service running. We could potentially change the host, but Right now it's set to this Unix var run docker sock little thing that is the default path at the moment for running the container server that's inside or that's bundled with your XNAT. We could also specify a different or add more image hosts. Docker Hub works fine for now, so we're going to continue to use that. We could potentially, and there's elements of this screen that I've deliberately whited out or just kind of ghosted in. We know we want functionality, we're not sure what that looks like yet, and so this is kind of placeholder-y, don't look there, kind of stuff. But what we can get in pretty quickly into how do I add images to this Docker server that's bundled with my XNAT. And we talked about two different methods, the being able to pull from an image host like Docker Hub or being able to load an image file. And I'm going to show you quickly a mock-up of how easy that would be. First of all, I can show you that there already is this BusyBox image, perhaps that came default. We can show you, calling it an image key here, that actually should be an image ID. But that's strictly so that I can kind of transfer some of the things that Flavin showed you into and showing you how it relates in a UI. That might not actually get showed to users, unless they really want to see a bunch of hash. But we could pull from an image host, and if you were to go and browse on Docker Hub and search for Python, for example, you would get a page, I don't have it open, but you would get a page that gave you this Docker pull command. And you say, okay, there's my pull command, I'm just going to type that in here, and we can parse that and just grab the part of it that we need, which is the name of the package itself, and we can pull that image, and you can add a little description in there if you'd like. Get a little, Doobly-Doo, and then there it is. And it's basically the same thing is happening behind the scenes that Flavin showed you on the command line. So there was a little bit of a download process, there was a little bit of just inserting it into the server. It now knows that it's there, but we have yet to enable it in XNAT. That's going to come in a second here. We could also load an image file. If you have a local copy of a tar file or something of that nature, you could upload it. You can add your own description to it, and then load that up. Same type of process. Maybe it takes a little bit longer. Maybe it doesn't. And as you can see, we have these. XNAT knows these images exist because it's polling its container server. You could, if you start getting a lot of images that you're dealing with, you could restrict your lists. Show me the things that XNAT is enabled. And can run right away, or show me things that are on the server only, etc. You could potentially, search through your list. But we can enable. I have a script that we could run in this Ubuntu package, and I want to call this image something unique. And we probably actually want to give XNAT a little bit more information than we are right now. I think we want to tell it what types of commands it can run. That's going to be. This is. I'm veering out of presentation mode into internal developer conversation, but there's still quite a lot here that's in flux. But you'll see why that's important in a second here. So now we have enabled this image in XNAT. It now has an image ID in XNAT. Again, I'm kind of showing you these things. They may not get shown to the user, but I'm trying to connect the dots between what you saw in Flavin's thing to what we're seeing now. And there are no commands as of yet defined for this package. And I think probably the most difficult part of the UI is going to be this command definition stage. This is where that kind of essential transfer of knowledge has to take place, where someone who knows how to write a really good shell script or write a Python script or etc. can codify and teach XNAT how to run that same thing and teach it to run via Docker. And so there's a little bit of, I don't know that we want to have those people that are excellent at writing those scripts to have to learn how to write them in Docker syntax. If they could just do it all in the command line or do it via the uploading the, catting the Docker load file, or I'm sorry, what it's called, and do it that way. if we want to give them a UI, it kind of implies that we don't want to have to force people to learn that much. So instead of saying Docker template, Docker run, image name, bin sh, then my command, we say, okay, what command type can this image run? And we say it can run bin sh, it can run bin bash. If you're running a bin sh, it knows to pre-format your template with these prefixes, and then it gives you a space to type in whatever command it is that you're going to run. If you wanted to, and this is where things started to get a little hairy, you can make elements of that command variable so that you can pass a variable forward to provide a value dynamically from XNAT. You can also specify your input mounts, your output mounts, etc. in this same kind of fashion. And I'm still a little bit unclear about the best mechanic in the UI for allowing people to kind of specify this syntax. This is going to be something that is a learning curve for kind of everyone involved, and we're going to try to lower that learning curve as much as we can. But at the very least, now that you've defined a variable, you have to tell XNAT what kind of variable it is. If it is an enumerated variable, what values should it expect? If it's a Boolean, what does true mean? What should true represent in this context? Should it be true, 1, yes, et cetera, et cetera. So there's potentially a lot of arduous configuration that has to happen in this stage. I'm not sure how much difficulty we can take out of that, but we're going to try to take as much as we can. But this becomes really important because doing the difficult part here makes creating actions much, much easier. So now I've got this command associated with this image, and we're going to give you just a little bit of information about it. You can go back in and edit it. Duplicate it, tweak it, etc. But now I'm going to go and look at, start to configure an action that users could run off of that command. Right now there's nothing, so I'm going to create an action. Why doesn't that button work? There it goes. And I'm going to use as my command base for this action the one command that XNAT knows about right now, which is this message test. So I'm going to open this action template. There's a process where, I don't know if it's actually going to take that long, but I want to show that there's a consideration of, okay, how is that command built? What does it find in there that needs to be passed forward into the action configuration? And it found one required variable, which we call the message. It didn't find any input mounts. It didn't or output mounts, but it could have, it would have in the DICOM to Nifty example. And so now that it knows this, it knows what it's going to require the action definition to do. And the really key thing here is that the person, again, who is loading images and creating commands should be an expert in that area. And there's tons of documentation around an image if you want to know how to do commands. If your image was Git, you'd have to know how to define a command for git clone, git pull, git destroy, etc. So there's documentation available to learn how to write those commands. The person who is defining an action might just be someone who's coordinating data inside of XNAT, and they just want to give an image uploader a quick and easy couple of tasks to run. And so they need to be able to take these values and say, okay, I only have to make a few little connections, and then that action is ready to go and could be run. But I do need to define what context that action can run in. So I know that this test I want to run in an image session. We could potentially add conditions here, and again, I don't know what this UI looks like yet, so I've just kind of blotted it out. It's a thing, it'll happen. But you could potentially say this session has to have scans with type of DICOM or DICOM scans. It needs to have a free surfer attached. It needs to have a T1. If you want to do some kind of a structural analysis. that's where you would define these conditions in your context. But now that I think about it, this particular thing is a little test message. It could really run anywhere. Well, so first of all, actually, before I get to that point, now that I've defined a context, which is this XSI type of an image session data, I would like to be able to pull a value out of XNAT and use it for this value. And to do this, we need something that we don't currently have, which would be just a generic data dictionary that knows, okay, for an image session type, I know that these values will always exist. If you were defining this action for a given project that you had added custom data to, from Jenny's example, was that Monday or Tuesday? Then your custom data types would show up in this list as well. So there's potentially a lot of configurability, a lot of power here, but for now, I just want the label. Or you could say, you know what, I don't know what I want. I'm going to let the user give me whatever the value it is. And so when the user would go to launch the action, they would be prompted with an input on the screen and say, please give me a value for this thing. And then they would have to do that before they could run. You could also add more additional contexts. And a subject also has a label. Actually, it doesn't have these things, but that can, but in a project, the structure of a project doesn't have a label, so you'd have to specify, let's use name instead as its field. But you could potentially run, so you're kind of seeing how these connections can be made in different contexts for the same action. And when you save this, then the action will be available in like a run processes menu in each one of these contexts in the front end user, for the front end user. So we're going to save that action. And I've also kind of jumped ahead in time here. We have several more actions that we could potentially be doing. The DICOM to Nifty example, something that James talked about is with the Radiologics team, being able to take a session that has been uploaded and compare its structural scan to another structural scan for that same subject to make sure this is the same subject that I'm uploading a scan for. If the structurals were too different from each other, that would be a big red flag. That could be a really valuable use of a quick container process, just immediately flag on upload. Something went wrong here, you probably uploading data to the wrong subject. And then here's my test message thing that I just created. You can see it has multiple contexts. You can see for the structural comparison, there are two other conditions aside from being an MR session that have to be true, or I guess one other. It has to have this scan, and the scan has to be called either T1 or MP-Rage. Just want to be able to make sure that you can read that up there. So then let's jump from the administration screen, and I'm going to mask pretend to have done a search just now. And this is what a session page, could potentially evolve into in terms of its design. And there's this actions box, which is familiar. And now we have this run process menu item in the actions box, and you could run this test message action. Send a quick little command to the container. Process is complete. This action really doesn't do a whole lot, so it's not going to give us a whole lot. But at the very least, it can give us an indication that it ran successfully. But as Flavin was saying, containers also give us a little bit more control if you have a process that takes a little bit longer to run. Maybe this structural comparison takes a few minutes to run, and here's my status. It started at some time ago. It's only at 10%. Maybe something went wrong. So you could potentially pause it to debug. You could resume it, you could restart it, but if you get a sense that it's just not going to complete, you can kill it. And that's where we hope to get. And again, this is all kind of forward-looking, and maybe some of this gets blown up and redone, and we discover that, that's too crazy. We can't actually provide percent values or something of that nature. But this is kind of where we want to get in terms of an ease of use for setting up actions and for running them. And I think now I can give the floor back to you, or are we going to take questions, or I guess we'll do that at the end? Okay, very good.
You want to ask Will a question?
Absolutely. When you set up the actions, it's really easy to transfer that. So just say I made some actions using follow control. How would I then share that with the rest?
Yeah, so that's a really good question. So he's asking, what if I've created all these actions, how could I share them across the community? And as you can see, an action is inextricably tied to a command, which is then tied to an image. So what we would want to do is bundle all three things together, all three sets of information together, and share, here's my image that can run this command, that can run this action. Maybe that's done through Docker Hub, maybe that's done through the XNAT Marketplace or something like that. But yeah, it should be, because containers are so portable, any other XNAT administrator should be able to pick up that package of image, command, and action, drop it in, and if we would give them some kind of importer, but they would have access immediately to those same actions. That's really an aspirational, but I don't think a difficult to imagine aspirational goal for this process.
Okay, so let's come back down from Will's really nice looking UI. So yeah, let's think about some use cases. How can people run these? What's the idea? So let's say some user comes to the admin and says, I want to run free surfer. So the steps would be, okay, admin goes, maybe the user tells them what image they want to run, maybe the admin has to go find it. Okay, pull down an image. All right, configure the command, and then the user says, all right, now I want to make an action out of that, launch it from these things, and here's what I want to do, and then they can go run it. Or maybe the user says, all right, admin, here, yeah, I have a script. I've written this script that runs locally. It uses FSL. So the admin has to go pull the FSL image, and then I guess maybe the admin has to say, all right, I got to package up a new image. I got to put this script on this image, and now we're going to use this custom image, and then configure a command for it, action, the whole thing. But you can optimize that a little bit. Like, okay, the user comes to you with a script. The admin says, okay, let's get this FSL image, and then let's tell XNAT, this image, you don't just run a single command in this image. You can pass a script to this image. So they can, yeah, there's a new object in the hierarchy that I kind of didn't tell you about called the script environment, where the admin can say, this image runs FSL scripts. If somebody has a script that runs FSL, point it here. So then the user can go to the XNAT script interface, and they pull down from the dropdown, what kind of script do you have? I have an FSL script. Put it into the box, and you're off to the races. So yeah, these would be things, you can put an image with Python. Anybody who has a Python script, maybe you tell the users, yeah, I've got these few packages. You do R, MATLAB if, licenses may be an issue, but we'll see how we can not get around, but work with that. And you can put workflow engines in here too. That's kind of a use case that I would really like to see, is if the people who write the workflow engines can put a Docker image together so that they can accept users putting workflows into XNAT and executing them off in this workflow images Docker engine or Docker image. Yeah, and then the admin would configure those. Users can set them up. Okay, so now let's think not from the user perspective, but let's think from the developer's perspective. Say, I made some cool new algorithm, and I want to make it available to people. And so let's say the developer, makes a Docker image, puts it out there, and then says, all right, people, please use my Docker image. Okay, so XNAT admin hears about that, pulls the image down, and now users can run it. But they've still got to do all that command action configuration. So what if the developer says, all right, I would like people who run XNAT to be able to run my image, so I'm going to pre-prepare some of those steps for them. So we want to get sort of a kind of a metadata standard. I was talking to Gunnar about this because they have a very similar use case with Flywheel, so that you can be able to, when you package up your Docker image, say, here's what's inside it. Here's how I run this thing. Here are all the inputs that my command might need. so that when you pull it down into XNAT, you get those commands already. You don't have to be an expert in how this runs. The developer's the expert. They're the real person who knows how to run this thing. And so if they have defined these things in a field on the Docker image, which I will show you, there's this thing in the Docker image called the label. You can just put arbitrary key value pairs in there. And so what we'd like to get to, we, the people who are developing this infrastructure, there should be some way that people can write, here is a special particular key that I'll put in my Docker file that, consumers like XNAT, like Flywheel, can read this key and understand exactly how to run my image. And still, we haven't defined exactly what that's going to look like, but hopefully we get to that sort of place. So now, yeah, the developer can be a little more forward-thinking and think, I'm not only going to build this Docker image that can run my thing, I'm going to put information in there that tells you how to run it. And that would remove a lot of the configuration burden from the XNAT users. So yeah, what are the next steps? What are the next steps for this project? Well, hopefully, now that you've all seen it, you're all going to do the practical, which is going to teach you a little more. And then maybe you can give me some feedback. What do you want to see? This is all still in flux. If there's some use case that you have that I haven't thought of, tell me about it. Maybe I can guide my development so that your use case can work. Obviously, there are a lot of major features that we still need to finish, like Will's UI, for instance. The wireframes look great. Got to make those work. There isn't a lot of monitoring right now. Little secret, I can't actually upload files yet. You'll see in your practicals that okay, you can create some files, and then I'll say, now switch over to Docker so you can look at those files. So XNAT can't automatically import them yet, but it will before release. And yeah, what we showed you with the contexts, so you can say, yes, I would like to run on a session, I would like to run on a subject, things like that. I would like to be able to get it where you can configure, I want to just send you an arbitrary collection of sessions. So you could pull from a search, you could pull from anywhere. You just say, here, run on all of these things, this arbitrary bag of things, and you send that up to XNAT, and XNAT will be able to just run on all of those things. That would be a really cool idea that I'm going to do. And then, yeah, once I get all those things, I would like to get a release out to all of you, to anybody else who wants it. Test it. See if it works for you. And so, yeah, so returning back to our big idea, the fundamental tension of processing. Things are in XNAT, and you need to get them somewhere else to process on them. And so how have I tried to solve this problem with this new infrastructure? I want to make it really, really easy for you to get your stuff out of XNAT. You just tell us just a few things, and XNAT should know exactly what you want and where it should go. But I need some stuff from you. I need all of you to think about how is this going to work with what I'm doing? Like how if you're administering an XNAT, how are my users going to work this? If you have some application, how is my application going to work in Docker? Like, how does that work? Because if you think about that, if you go through that process, then you can tell me, no, your thing doesn't work for my use case. This is terrible. And then I can try to fix it. I can work with you, make it better. It's best to do that now, before I release it, than later. Yeah. All right. So yeah, you get a hold of me. Anytime you think of anything, email me, post on the discussion group. I'm always watching when people have pipeline questions. And go check out the code if you feel like. So it's all written in Java, unfortunately. So it works with XNAT. But yeah, it's all on GitHub. I don't like Bitbucket. So yeah, just go check it out. Post an issue if you find a problem, anything like that. I try to make myself available. And with that, thank you very much. I hope you enjoyed it. Questions? Yes.
Okay, so I have a couple. One, how do you envision this running on clusters?
Well, yeah. So that's a good point. So as we were talking about the other day, we had a little breakout session. My vision is that XNAT doesn't need to know that this is running on a cluster. XNAT speaks just to the Docker server, and then if you have some cluster that you work with, you make an image that knows how to send your jobs out to that cluster. So yeah, all of that sort of specific configurational knowledge you can put inside that image and send it out. And then XNAT only knows how to run commands there.
And then just, sorry, one more. So there's one use case I could see us doing where basically we go through a load of our atlases. So we have 200 T1 images that it's working with each one. I can imagine if we had a container for each one of those instances for running workflows, we're reduplicating what's essentially the same data that stays static the whole time. Is there a way to externally mount things into the Docker such that it's using the same copy rather than generating?
Yes. So the examples that you're going to do in the breakout, or the practical, those are essentially assuming that your Docker server can read your archive, like that you've got that mounted up. And so if they're on the same system, that's really easy. So in that case, it's not actually moving any files. It's not copying any files. It's just reading. So that would be essentially exactly as you describe. Everyone would have a different mount, but it's all mounting onto the same data. And you can mount it read-only so that they can't, remove anything. Yes?
So as a programmer, I kind of lost track of what's past, what was present, what's the future, what's the line between. So like what I'm thinking is what's going to make my life easier at the moment. And so what are the things that are already there as in for, I know pretty much what Mohana talked is definitely there.
Pipeline engine is definitely there, that's true.
Something that you talked about looks like is going to be in 1.7.
So I will say
the timeline for what Will is talking about.
Months. Timeline of months, I would say, is a safe bet. This is not going to come out concurrently with 1.7. But the nice thing is we're designing it in the XNAT plugin architecture. So all you'll need to do is, drop in that plugin, restart your Tomcat, and it's good to go. There won't be any big code changes inside XNAT. But yeah, as to what you can do as a developer, I would say just get familiar with Docker. Like from your side, that's what you should be doing. Learn how to put your stuff into Docker, learn how to run it from within Docker. Because the more effort you put into that up front, then the better it's going to be when people go to run your application later.
I think there'll be a useful first version of the plugin this summer. This is, as Flavin was saying, a multi-month ongoing project. So I think what I would call the turnkey, really ready to go version of this is probably next spring.
But there should be code that will run that you can put into your XNAT sooner than that.
But before it's what I would consider to be really solid, I think it's still many months away.
Yeah, Dan doesn't really want people to have to think about a whole lot when they're using this. Just like, it knows exactly what I want to do and everything works perfect. Which, I mean, is a really good goal. But it's hard. It's very, very hard.
We're also hopefully going to provide a number of steps along the way that you should be able to start moving implementations into containers and starting to leverage those even before you have a full-fledged, does all the thinking for you implementation of the system. We're really trying to serve everyone's job because when this starts doing all of this for you, we're all on vacation permanently. So, we're looking at more details. But one of the thoughts is to maybe have a pipeline that can launch containers. And so if you had that, you could already have your functionality in a container that'll only take that last step from the form that it's in there to a container that'll work with the whole container services framework. So.
Anyone else?
So does Docker have a bucket concept?
A bucket concept?
So like on the Amazon cloud, you can have a S3 bucket, which can be your staging area, and then you can pass the label of that bucket as an input to your container, and then it can just suck in all the data, do its stuff, and push the data out onto the same bucket or a separate bucket and give you the label.
So
staging is not your headache. All those IDs that you're passing.
Yes and no. I will say sort of the idea of the mount is somewhat similar to that, but Docker doesn't move the files around. It just sort of is able to take the files that are on the file system and kind of say, all right, the container now has access to that in this particular place, and you can reuse those like. But yeah, as to moving the files around where you only have to move it to one place, I would say, yeah, that's still going to be XNAT's job essentially to say, I have these things over here and I have to put them over where they're going to go, and then Docker can read them. Does that answer your question? I'm not sure.
That's an experiment we tried to brainscape when we did the Amazon thing. While we push the data onto a bucket, we pass the bucket label to our image, and then it just fired up and did the problem.
So yeah, to me those would be back-end things. Like I don't think the user should ever have to see that, okay, we moved your data here, and yeah.
How to stage the data is all they need to know. Or what data to stage.
Yeah, that's all they should need. Yeah, they should be able to say, what resource out of XNAT do I need? And
Data state or where it staged is all backend. They
Yeah.
need to be aware of that. But what data needs to be staged is something that you can even share. Like, fill in the
yeah, that was another thing that somebody suggested the other day, is that not that XNAT sort of proactively moves your files, but it's possible you could just pass over a URL, and then whenever the application runs, it says, okay, here's the URL to where the files are, I'm going to download them. So we could do that as well. It seems like it would be more useful, though, to just have the files there. Don't make any assumptions about how they're going to use it. But I guess we should support both. But yeah, I'm not exactly sure. It seems like we would do the same thing as the Amazon buckets, but I'm not exactly sure about the details, so can't answer authoritatively. Anyone else? Yes?
Along the lines of staging data, it seems like there are sort of two issues. One of them is a single instance where you're running a single, not to use the word single step in a container. Whether you stage the data or not, that's easy to understand. From the point of view of what you're writing for XNAT, I think it would be really valuable to have a checkbox, a set, an option that says, hey, this pipeline will consume data and produce results that are then used by additional pipelines. In other words, if I've already moved a lot of data around, particularly if you're moving from across firewalls and so forth, to get something out of your ZFS file system onto an HPC cluster, you don't want to be throwing away that data with each pipeline step, even if they're completely separate. But that coordination has to happen at the XNAT stage so that it knows there's a persistent scratch store for this series of pipelines, but it should be securely removed at the end.
Yeah, so that's not something we do now, but I can see how we could support that.
And that goes back to what you were saying in terms of basically passing a pointer to where the data lives rather than copying it.
Yeah, so you'd have to have this connection between, okay, I already ran this one, and I want to take its outputs and feed it to this other, because the path that it wrote the outputs, the first one, will be recorded, and so we just would need a way to connect, like, all right, this is a thing, this path, it'll already be there. So, and then the user would not have to worry about any of that. They just say, this output now feeds this input. And so then XNAT would understand, it's already going to be there. I don't have to move anything around. Yeah, that's a good idea. I like that.
But yeah, I think the whole notion too, just kind of the building of number of connections within this system. I know the Human Connection Project has a whole string of pipelines that run consecutively as they do their extensive processing on their data. And it would be really valuable to just have that handoff get managed, at this kind of data layer, or at that processing layer, without and also, but with the advantages of being able to pause in between the steps, make sure that that step just executed properly and is producing good results, and et cetera. So yeah, absolutely. And I think also kind of on the front end too, not exactly answering your question, but kind of going beyond it, is the ability for one action to consume another action as its input and say, you know, I'm going to run a meta action that's going to run a series of actions in a row, you know, you know, I have a whole table full of MR sessions that I want to run this action on. Let's just batch that up, you know, and run them all consecutively with one click. I mean, that's kind of the goal of where we want to get to as well.
So now I've had more time to think, and I don't know that I like your idea anymore. And so
I spend a lot of time around it, because that always happens.
it does. So here's why. Because what I'm thinking is, if, you know, like I was describing earlier, if you've got a lot of, you know, specific knowledge of exactly your computing environment, it's my idea that that would be done most easily by you making a Docker image that knows about all those things, and that thing can run your jobs for you. But so then that means your image would understand, if I have these multiple steps, I know that I can use these paths again, and these resources will be there, and so forth. So that doesn't necessarily mean that XNAT has to know about that. XNAT doesn't need to do that coordination. You can write a piece of software that does that, put it into a Docker image, and then that thing can handle all that for you.
So it's the dichotomy between whether you run things as one big black box that runs all the separate steps, or you have the separate steps controlled by XNAT where you can do QC between each step and provenance for each step. So
Yeah, and I think
it's just, and you can have both. I mean, it's a philosophical.
Yeah, I think as much as possible, I would like to get XNAT out of the game of having deep knowledge of multi-step workflows. Because I think there are very good tools that already do that, and I don't know that that's where XNAT can add value. XNAT adds value by giving you XNAT data. That's really our core competency. We have data, we need to give you data. Having XNAT manage individually each one of the steps in your workflows and have all this knowledge of computing environments, it can be useful, but also maybe not necessary. So, but again, you know, I'm still kind of on the fence about exactly how much of that integration is going to be there.
Well, I mean, part of the point of the database is you can have access to all the downstream. For me, it's something that
Well, so wait, what do you mean by that?
just so you have access to the raw data, you have access to all the process files.
Well, and that'll still absolutely happen. Yeah, like XNAT will still be able to soak up whatever processed files you make, put them back into XNAT, and now you can use them again for something else later. But yeah. So yeah, I don't think we're saying different things.
I think you still have to track the provenance of the data.
Well, yes,
And it all,
that is true. Absolutely, we need to keep track of provenance. But I think it's our responsibility to store it. It's not necessarily our responsibility to generate that. That should be whatever is executing all those steps. That thing needs to generate the and we can generate provenance in that we know this person ran this action and had these parameters, this you know, all that stuff. But knowing what's inside that black box, we can store that. If you produce that inside the black box and say, here's all the stuff I ran, you know, XNAT can store it. But having XNAT go in and track each one of those things individually, I think that is less valuable for us to do. And more, the black box itself should know, I'm doing all this stuff, I really need to report it. Because that's where the information has to come from in the first place. Something needs to know what's happening and report on that. Yes?
So a lot of workflows these days use the WC312 stepper.
Yes.
It generates whole files, contains a lot of information about what's done. So it's actually expensive thinking about supporting such a thing that you have it as
Thinking about, yes. I would say that's a good description.
accessibly that actually there will be classes along so it can be ventilated properly.
Yeah, I think that would absolutely be useful if, you know, if the output were generated in that format, that we would be able to incorporate it. And then we would have knowledge of all the individual steps that were run. Yeah, I think that's something we could do, yes.
So what's your approach to security going to be for this? Because I can see that there are some Docker images that are going to have admin privileges for accessing the XNAT database. And is it going to be left to the role of the local site admins that if they allow this Docker image to be added, they take responsibility for whatever's in it?
So I would say, okay, so there's two things to think about with the security. There's within XNAT security, what data can you see and what can you do? And so, we've already got a good security model for that, and it should stay similar, like these users are able to see this data so they can run processes on it. We would like to maybe make a few extra roles, like, okay, you can install containers if you're a container admin, which is a role that doesn't exist yet, but you shouldn't have to be a site-wide admin to pull these things down. We want some additional privilege there. But yeah, then there's also the security over here of once a container is running, is that user able to become root? Is it able to break out? And so that's essentially, we leave that to Docker. And I think there are generally concerns with Docker that the system user that can run Docker must have admin privileges, essentially. That's how Docker runs. And so there are some kind of attacks where people can break out. But I think we don't fall into those security holes because we only have one user. The XNAT user is doing all these things. And we know the XNAT user, we know exactly what commands we're sending to Docker. We know I'm not going to write any code that escalates privileges. And so that the things we allow users to create won't be able to break out of the container because they don't execute on the host. They only execute inside the container. The only stuff that executes on the host is basically me saying, please run this command. Please show me the logs.
Haven't you said that essentially what you've got on the Docker container is essentially a pointer to somewhere on the file system, or the XNAT file system?
They can read those things. Yeah, those will be mounted read-only, though. That's correct.
So I just want to ask a question to your question.
Yeah.
Are you concerned from a kind of a technical side of security, or is it more of a, or is it both?
It's
that and the liability side of security. Like this person uploaded this image and something bad happened to our data. And we didn't know it at first, but now we released it and there's something catastrophic. I don't know. Is that a serious concern that's in the back of your mind?
So, well, I think that there's both. Can somebody come up with something in a Docker container that can screw up your archive?
Right.
You're saying it's mounted.
Yeah, the files are read-only, and it can't read the database. Yeah, we've only allowed them to see what you put into the container in the beginning. Yeah, that's right. Yes.
Can you speak a bit about Docker's versioning process? Because it seems to me that you're leaning heavily on that. In the projects, essentially you run this particular version of this particular image.
Yeah.
You might have talked about it earlier, and so I apologize for asking the question.
I guess my understanding of Docker's versioning is that when you tag a new image, well, or like each individual image has a unique ID based on what's in there.
A massive shard thing.
Yeah, yeah. And so, so we don't rely on sort of the tag for the version information. We don't say like, oh, well, you say this is also Ubuntu, even though it's something you created and put up there. Like, we keep track of the unique hash. And so if somebody wants to update that, pull down a new one, that's essentially a whole new image. And
is there some kind of guarantee that old images would be available from Docker Hub? Or do we lose them over time, or are we responsible for that?
That's a good question. I don't know. I don't know. If that is something you are concerned about, you can always create, export these images and keep them as tarball. Yeah, if that's something you really want to keep them around.
He's asking if Docker Hub is guaranteeing a long-term stability of older legacy versions of images, and we don't know the answer to that.
How do you control sort of the memory that the container uses? Like, can you control how much RAM it has? Or?
Yes, you can control those things. We haven't exposed that in the UI. If that's a thing you want to do, I think we can. Yeah, that is part of the Docker API. We could set those things.
Images itself is what I was thinking. I don't. Once we have an image, I don't think we would say, well, I want 8 gigs for this time or 2 gigs for this time.
Let me think.
I wonder if you would specify it in the image or if you would specify it at runtime. Like, I mean, the memory requirements might differ between a one-time versus like a batch operation or something like that nature, or depending on how many different processes you expect to be happening in a given time. It's really a question. I'm open to how we might answer it.
Yeah, I think that could be part of the command definition. When you say, when this image runs, ask for this much memory, this much CPU, that kind of stuff. Like, that's definitely something you can configure. So yeah, if that's something you want, we could do that.